Hey guys, it's Mike from Shimino's Workshop. Just wanted to do a follow-up video on the NeoPixel, Dimitri's NeoPixel PCB. I have another one that I've installed, this time with the short pins. And Dimitri had sent over another device that is much better for testing. It's made by BTF Lighting, the same company that a lot of us buy our NeoPixel strips from. So this is the SP105E. It's called the Magic Controller. It has Bluetooth excuse me, built into it so that you can actually control it from your phone. And it has a bunch of outputs for ground, for data, for power. Right, so your three wires that you should be familiar with, and you can also buy a power adapter. I think I went with the 10 volt 50 amp. There was a couple of different amp options, but I think I went with the 50 amp. So together, maybe it was about 40 bucks. 20 for the controller, 20 for the adapter, if I remember right. Bought it from Amazon, got here pretty quickly with Prime. And so, real quick, I can show you on the app, there's, when you start, it's going to show you all of the different Bluetooth devices, which is kind of interesting. So here is SP105E. I believe it was, when I first did it, it was unnamed. So I had to kind of go through the unnamed devices until I found the right one. Now it shows correctly as SP105E. So if you select that, it's currently off, which as you can see, it's off. So if we go to the settings tab, you can see there's many options for the color order as well as the type. There's not a 2812 or 2812B, so I just went with 2811. And I went with GRB because RGB was giving me the wrong colors. So GRB 2811 is what I got to work. Maybe 6812, I don't know. I don't want to guide you down the wrong way. My strips are definitely BTF Lighting. They're WS 2812B. But since there's no option, I went with the one that worked. Then you can set your total number of pixels. So you could do 5 for if you're testing just the 5 onboard pixels. My demo blade has 42. So I can change it to 42, hit confirm, get your total pixel count updated. We can go back. And then down here are some speed and brightness. Once it's turned on, you'll be able to adjust the speed as well as the brightness level. And then up here is an auto. Well, it says, I guess you can't play with it until you turn it on. So I'll turn it on. So there's just that switch. So that turns it on. And then as you can see, you can adjust the brightness level as well as the speed of the effect. Over here are just some preset colors. So you have warm white, red, green, blue, white. Now these, and this is how I knew, I'm just going to shut it off so you can see the phone. This is how I knew that the color order RGB, GRB was wrong, because when I pressed red, I was getting blue. When I pressed green, I was getting red. So I just changed the settings, this setting here, until I got the right color. You can also spin the wheel and just get a static color. If you hit the circle, that is auto mode, and I believe what that does is it just cycles through all the modes. So if I click auto, then down here you can see there's 200 modes. It's just different effects. Think of it as like effects or in your presets or your styles. So it has 200 modes predefined, as well as your static colors. So if you just hit that, you know, you can kind of just let it cycle through all the different modes and confirm that things are working properly. Now the other thing that we can do here, which was pretty cool, so that was the blade test. If I take the blade out, right, we still want to be able to confirm that the 5 pixels on board are working properly. Now this is going into a CF10 install. CF10 doesn't, the LS2 pad is not currently implemented. So I can't go version 4 with this PCB install. Version 4 allows the blade to be programmed independent of the 5 pixels. So that gives you the greatest flexibility, so that in your config file, if you want them to style the same, you can. If you want them to style differently, you can. On Profi, you can go I think it's version 3, which is the series configuration option. And that allows, what that does is, using one data line, the signal first goes through the PCB pixels, then goes to the blade. So on Profi, you can use subblades to make it work like version 4, using one data line. So the 5 pixels would be blade 1, the next 42 pixels, so a total of 47, but the next 42 would be blade 2. So you'd essentially still have 2 blades using subblades, and I can control these 5 independent from those 5. So version 3 is a nice fallback, but on CF10, I do not believe it supports the concept of subblades. So now I'm on version 2. Version 2 is in parallel. That means one data line, and in this configuration where I have 42 in my blade, 5 on board, in parallel just means that the first 5 pixels are the same as the first 5 pixels in your blade, which, sure, you know, I'd say that's real basic, right? Because the first 5 pixels really don't ever do much in the blade. Drag, you'll never see a drag effect. Blaster, which is random right along the total length pretty much. You'll never see blast effects, lockup. Unless the effect occurs in the first 5 pixels, you won't ever really see much in version 2, but kind of out of options with CF10. So with that said, this is in V2 mode, which is the parallel mode. And if I turn it on, right, we can see, because I'm still configured, if I bring this closer, I'm still configured for 42, but I'm getting the first 5 pixels. Now, if I change the pixel count, let's say to a standard 36-inch blade count, which is 130, I'm still going to get the first 5 to appear. And then the same thing if maybe I change it to 2. Right now we can see that it takes effect. Now it's only 2 that's appearing. So this is a nice, real nice way of testing your pixel adapter prior to doing the install. So let me go back, shut it off. So this is an actual blade holder. This is like the deluxe blade holder from the Graflix shop, because I needed something that could hold. You know, and then what I did was printed a PCB. I don't have my Allen key here, but there's blade retention screw here, which you might not be able to see. But that's just holding a little 3D printed holder that I printed with my stock PCB in it. And this way I can, you know, mount it securely in something. I can test whatever 1-inch blades I need. If I have a 7/8 inch blade, if I have a 7, yeah, I know, Alexa. If I have a 7/8 inch blade, then, you know, I could probably put that into a 1-inch blade, or Dimitri even sells a 1-inch holder. So I hope this was helpful. This was really great. I'm glad Dimitri, you know, showed me what this is. I think even KR Sabers use it. Okay. All right. Well, thanks for watching. If you guys have questions, if you'd like to see something else, hit me in the comments. Let me know. I'll be glad to do other videos.